Hello everyone. In this video we are going to study about another colligative property, that is elevation of boiling point. So before going through this video, please watch the video related to what is colligative property. The link of that video is given in the description box. After that you can study about the first colligative property, that is relative lowering of vapor pressure. That's also given in the link is given in the description box. And after that, please come to this topic, that is elevation of boiling point. So we will study this colligative property by seeing each of these words. So, what is boiling point? First, let me take the term boiling point. So, you know that if you take any liquid, pure liquid, what is boiling point for that liquid? It is the temperature at which the vapor pressure of the liquid that will be equal to the atmospheric pressure, right? So boiling point of any liquid is the temperature at which vapor pressure of the liquid becomes equal to atmospheric pressure. So now we have a term elevation of boiling point. So what is the meaning of that word elevation? Elevation means elevating, that means increase of boiling point. That is one colligative property. So to understand this concept, let me take example of water. So think that I have taken water in a beaker, and if I heat, when the temperature of this water becomes, when the vapor pressure of this water becomes equal to atmospheric pressure, this water boils. So the atmospheric pressure is 1.013 bar. So when the vapor pressure of this water becomes equals to 1.013 bar, this water starts to boil, and that will be the boiling point of water. And you know that is equal to 100 degrees Celsius or 373.15 Kelvin. Okay, don't bother about the unit. I can take it as 100 degrees Celsius. So this is what usually happens. So I can tell each liquid has its own specific boiling point. Like water, which is having 100 degrees Celsius, other liquid will have some other boiling points. Now we have to see what happens to boiling point when you add one non-volatile solute into solvent. So let me take one specific example. Let me add sugar crystals into this water, same water, so that I got sugar solution. Now, will the boiling point of this solution same as the boiling point of pure water? No, there will be change. So as I add the solute into the solvent, the boiling point of that liquid or solution also changes. So you know that when you add a non-volatile solute into the solvent, what happens to vapor pressure? The vapor pressure will decrease. Okay, if vapor pressure decreases, will it reach the atmospheric pressure easily? No. It is very difficult to reach that value of atmospheric pressure if the vapor pressure of the solution decreases. So, since vapor pressure of the solution decreases, for example, in case of this sugar solution, though you provide the boiling point of water, what is that value? 100 degrees Celsius temperature, this sugar solution, it won't reach the value of atmospheric pressure. Here, the vapor pressure will not be equal to the atmospheric pressure, though you provide the temperature related to boiling point of water, that is 100 degrees Celsius. Because since there is presence of solute, you know that according to the colligative properties, relative lowering of vapor pressure we have seen there. So when you add non-volatile solute, the vapor pressure decreases. So you can't reach atmospheric pressure when vapor pressure is decreased, though you provide 100 degrees Celsius temperature. So what is understood here? to reach atmospheric pressure, this sugar solution has to be provided with the temperature which is greater than the 100 degrees Celsius. Whatever the temperature you provide, that should be greater than 100 degrees Celsius. Then at certain stage, it will reach the atmospheric pressure. So what's your conclusion here? By this two examples, we can tell the boiling point of the solution is always greater than the boiling point of the pure solvent or pure liquid. But in case of vapor pressure, we have studied vapor pressure of pure solvent, it is always greater than the vapor pressure of solution. Vapor pressure of pure solvent is always greater than vapor pressure of solution. But here what's your conclusion? It is the reverse of that. So the boiling point of solution will be always greater than the boiling point of solvent. Please remember these two different concepts. Vapor pressure of solvent is greater than vapor pressure of solution, but when you come here, boiling point of solution is greater than boiling point of solvent. The reason you know here. Okay. So, to understand this concept clearly, let me take the graph. So, see the graph here. This is the graph of vapor pressure versus temperature. And here there is a curve for solvent which is represented in red color and a curve for solution which is represented in blue color. So here it is seen that as temperature is increased, the vapor pressure of the solvent goes on increasing, and at particular temperature, that is at this point, TB0, let me represent that temperature as TP0. At that point, the vapor pressure of that solvent will be equal to atmospheric pressure. So the point or temperature corresponding to this point, it is called as boiling point for this solvent. But when you add non-volatile solute into that solvent, it will change into solution. Now the curve for solution is in this manner. So it is seen that as the temperature is increased, vapor pressure is increased, but actually the vapor pressure should become equal to atmospheric pressure at this point. That means at the temperature which is provided for that solution. With the same TB0 temperature, the solution also should attain that atmospheric pressure. But it is not like that here. It should be, the temperature should be further increased so that the solution will acquire the vapor pressure of the atmosphere. Okay, or it will attain the atmospheric pressure. So this much amount extra temperature has to be given for that solution. So that tells that the boiling point of solution is always greater than boiling point of the solvent. Here you can understand this temperature axis is towards right side. So here it is understood TB0 is lesser than the TB. So now there is difference between these two temperatures. So that is called as elevation of boiling point or elevation in boiling point. So we know that TB will be greater than TB0. So to find elevation in boiling point, which is represented as delta TB, you have to write TB minus TB0. Not TB0 minus TB, it is TB minus TB0. Why? Because the boiling point of solution is always greater than the boiling point of the solvent. So that is about elevation of boiling point or elevation in boiling point. In the next video, we will study about how to determine the molar mass of solute by using this colligative property, elevation of boiling point. Thank you.